Okay, so we're going to be taking a look at some solutions to 3.6. There look to be some issues, maybe. So in 3.6, oops, number 9, we want to use the variation of parameters formula there. And so to solve 4y double prime plus y is equal to 2 secant t over 2. And I think initially some people were having trouble with the secant, so just go ahead and convert that to 1 over cosine t over 2, and just go ahead and drop the 2 in there too. Good. So that'll make things a little bit easier. Whoops, I see an issue there. That should be a 2 on the top. It's going to come down here in a second because we need standard form first. So I need to divide this 4 out, right? So I'll have y double prime plus 1/4 times y is equal to 1 over 2 cosine t over 2 now. Okay, and so I need y1, y2, the Wronskian of y1 and y2, and also g. Okay, and then I just plug everything into the formulas and see what happens. So for y1 and y2, we look at r squared plus 1/4 equals 0. So r is equal to plus or minus 1/2 I. And so let's go ahead and take y1 to be cosine of t over 2, and y2 will take to be sine of t over 2. And you could have reversed these if you liked, doesn't matter, as long as you're consistent. So once you've assigned labels to them, you don't want to change those labels. Okay, so now we'll take our Wronskian. So that's a cosine of t over 2. So derivative is going to be minus 1/2 sine of t over 2, and then it'll be a sine of t over 2, 1/2 cosine of t over 2. So that's 1/2 cosine squared plus 1/2 sine squared. So that's going to be a 1/2. Good. Do we have all our pieces now? G is equal to this quantity. Whoops, not that quantity. G is equal to this quantity. Good. And so now you just plug everything into the formula. For U1, I like to do it into U1 prime first, although it doesn't matter. Minus y2 g over w. Go ahead and simplify that. Minus y2 is sine t over 2 divided by we have our 2 there, 2 cosine t over 2, and oh, look at that, the 1/2 and the 2's cancel. Oh, that's nice. Good. And now we need to integrate that, and so when you're integrating that, you just take u to be we're going to do a Udu substitution. U is cosine of t over 2, so du would be minus 1/2 sine t over 2 dt. Oh, what just happened? Okay, sorry about that. My screen flipped around there for a minute. Not sure why that did that, but okay. So now we just plug things in. This is going to be what is that going to be? 2 times the integral of 1 over u du. So that's going to be 2 times the natural log cosine t over 2. Good. And so this is equal to u1. Okay. And now we go after u2. That's going to be y1g over w. And just again, plug things in. That's going to be cosine t over 2 divided by 2 cosine t over 2. That's our g, right? There's 1 over that. Times 1/2. 1/2 and 2's cancel. That's equal to 1. And so u2 is going to be t. Good. And now our particular solution is u1 y1 plus u2 y2. And again, plug everything in. U1 was equal to this expression. So y1 was cosine. So we have a 2 cosine t over 2 natural log cosine d over over 2. Okay, so that's that expression. U2 times Y2, that's going to be the sine times t, so that's going to be t sine t over 2. Good. And so that is our particular solution. So for the full general solution, you would want to add, where's my y1 and y2? Here you go. Add in your general homogeneous part as well. Good. So for this problem then, I think mainly you just have to identify the pieces to the formula, plug the pieces in, and then put the pieces together at the end. So we'll just set up number 13. 13 is almost identical. You just have to get the pieces right. For 13 we have t squared y double prime minus 2y is equal to 3t squared plus minus 1, and we're told that y1 is equal to t squared and y2 is equal to t to the minus 1. So that makes that a little bit easier. T is greater than 0 if we need that. I'm not sure that we actually necessarily need that for our algebra. You don't want to leave your answer or leave your differential equation in that form. First we have to divide by t squared to identify the g. So that's going to be 2 over t squared y equal, now this is going to be divided by t squared, so I'll just simplify that. Okay, and this is now g of t. Okay, so now I have y1, I have y2, I have my g, the Wronskian, t squared 2t, t to the minus 1, minus t to the minus 2. That's going to be minus 1, I guess, huh? And minus 2, minus 3. Wronskian's minus 3. Good. And now we take u1 prime equal to minus y2g divided by w is minus t to the minus 1 times g, which is 3 minus 1 over t squared, right, divided by the Wronskian, which is minus 3. Good. So then simplifying that, the negative signs cancel. I'll have a 1/3 there. 1/3, bringing the 1 over 2 t, since I'm going to have to integrate 3 over t minus 1 over t cubed. And then before we integrate, we'll go ahead and take that to be 1 over t minus 1/3 t to the minus 3, right? Good. And then you just integrate that. And so the u1 is equal to the natural log of t. And then for the other one, what do we get? T to the minus 2 power plus 1/6. Good. Now this does not have a plus c on it, right? Good. And similarly, u2 prime is equal to where's the y2? It's a y1g divided by w, and so that's going to be where's y1? T squared times our 3 minus 1 over t squared divided by minus 3. And you see a bunch of stuff cancels out, right? We end up with minus t squared plus 1/3, I believe. That's easy to integrate. So minus 1/3 t cubed plus 1/3 t. Good. u1 and u2 are found. Now our particular solution is u1 y1 plus u2 y2. Okay, and I'll leave you to plug those in, because now we have all 4 pieces, right? All 4 pieces have been computed. Very good. So that's all variation of parameters is. It's really just a plug and chug kind of thing. Okay, so I wanted to talk about the handout solutions as well. So we're using complexification to solve a couple of problems. Handout for 2c, we're taking a look at y double prime plus 2y prime plus y equals cosine of 2t. Okay, and so again, the idea is that we're going to embed this into a bigger problem, right? So I'm going to write that as cosine of 2t plus I sine of 2t, which is e to the 2it. Okay, and once I solve the larger differential equation, then because I want the cosine, I'm going to be looking for the real part of our solution. Good, so then I take my ansatz to be a e to the 2it. Yp prime then would be 2I a e to the 2it, and you're treating the I just like every constant. So now I have 2I squared, so that'd be 4 times I squared, which is minus 4. Plug things in. Oops, that was the second derivative. So I'm going to factor out that e to the 2it, and I'd have a minus 4 for that. 2 times my 2I a is going to be 4I plus 1 is equal to e to the 2it. So e to the 2it's will cancel. A is equal to 1 over minus 3 plus 4i. Good. Now, what to do from here? Well, the long way around is to say that we want the real part of a e to the 2it. And so we need to compute that quantity, and so if you do compute that quantity, you'll have 1 over minus 3 plus 4i times cosine of 2t plus I sine of 2t, right? So that's equal to, I need to multiply by the conjugate. That's over 9 plus 16 is 25 over 25. And so I get this times cosine 2t plus I sine 2t. Okay, and then once you multiply all this out, then you get to your answer. However, there is a shortcut. And do you remember what the shortcut is? We can write our particular solution as r cosine omega t minus delta, where r is equal to 1 over the magnitude of our a. I shouldn't write that. If a is equal to 1 over a plus ib, I'll write it that way, then our r is equal to 1 over the absolute value of a plus ib, and then our delta is the inverse tangent of b over a, and that's the 4-quadrant inverse. So I may have to add pi if necessary, and then the omega just comes from the original problem. Okay, so in this case, my y sub p is equal to 1 over the square root of 25, which is 1/5. The delta. Now the delta is that b over a, right? So in our case, where's our b and our a? Minus 3 plus 4i is what we're looking at here. And so where is that on the complex plane? Go down, minus 3 plus 4i. It's over here somewhere, right? When you take the inverse tangent of b over a, you're going to get this angle. And so we need to add pi to whatever the inverse tangent gives you. And so our answer here would be the inverse tangent of minus 4/3 plus pi. Good. And so that's not y sub p, that's r. Good. And so our y sub p is now 1/5 cosine of 2t minus delta. You can leave the delta like that and just indicate it with an arrow so you don't have to rewrite it. Good. And actually the next problem is identical to this one. So I think I'm going to skip that one. If you want to see it, just get in touch and we can go through it. See you later.